this network to PC2, what you are doing once you do the static routing, that's your lab 2 or 3. Once you do static routing, you are telling this particular router R1, please go follow this route to go there. You can't have a mind change anytime. You can't. Always you need to follow this route to go there. That's the static routing. Doesn't matter you have a network topology change, some network broken or whatever. If network link is broken, you can go there because that's the only route available to you. That's the static routing. Now, how we do the static routing? As you know, you must be in config mode to configure anything. So, if I'm from this side, my is actually intention to go that direction on my right. I'll type here IP route. Where I'm going to my destination. So I need to type here destination network address. I repeat, not destination host address. It should be destination network address. I want to go from this network over this network to this network. So this is my target destination. So I'll type here 2.1.2.2.3.0. See, .0, this is my network address. Okay. Now, destination network address, I need to type in. So I type, this should be in same line. Please remember, I'm typing as I don't have space. I'm typing underneath, but it should be in the same line. Don't press any enter at this stage. Just type the same line. So I want to go from here, and this is an R1 router. So I'm typing in R1, not R2. So I'm coming from this side, I'm typing in R1 router, I want to go this destination network, I type this, followed by the subnet mask. Now, there are two options for static routing. You can tell, okay, if you want to go there from here, you can go, you are using this serial interface as an outbound interface, you are using this, that's an option we call adjacent serial interface. There is one option. You can use these, either these, or you can tell, okay, as you're going always there, you must go to that address as well. Otherwise, how you can go there? So you could even type there next hop IP address. Please remember, you're not going to type both. You're going to take either adjacent serial interface, that's your own serial interface, no IP address, just the serial interface, or next hop, this is your next hop. If you are here, this is your next hop. Next hop IP address. So if I make this, so I should type here serial 0/0. That's my adjacent serial interface. This is possible, or I could type, if this is .1 and if this is .2 host address, I could even type 200.200.200.2 because this is next hop and this is that. So both of them possible, but you can't or you cannot use both together, either this or that. Now you may ask me a question, which one is better? Why there are two different options? Please remember and try to understand the concept. This one is better. If you even use this one, it will take a time to decide, okay, I'm going out of this interface, what's next? Where I should go next to go to my target destination. So it takes a decision time here just to find out where I should go next. Okay? But if you tell being here, okay, if I'm using my mouth and I'm grabbing that particular food, I'm going to get there anyway. I'm eat by my mouth. So I don't need to spend time, I'm going to use my mouth to eat something anyway. So go there, get the food, that's it. So you can go to the next of address directly. So now you need not to wait for any decision to take where you are going next after the serial interface. It's already fixed. You can only go there to go to your target destination. So this one takes less time. So it is better. But why we have two options still? Because the old iOS, old platform of router series, they don't understand the next hop address. They can't understand that. So sometimes you try implementing a static routing in old routers, 1700, 1900 series routers, and the RSSs are not updated, not the advanced one, they say incomplete command, wrong command, something like that. But if you use this one, doesn't matter old or new or current routers, it will be accepted. That's the standard. But this one, perfect for our routers 2811, 37, 38, 45, the new routers. Make sense? So this is the command. So this you should do for this direction. So if you do that, if you have your configuration appropriate right, if you have a configuration appropriate, this is fine, proper, then you should be able to ping from PC1 to PC2. But now you tell me, can you actually ping from PC2 to PC1 now? No. Why not? Because you haven't configured this direction in router 2. How you can go to that direction? You didn't configure that. So you need to do the same R2, IP route. Now in this case, your destination network is this, followed by your subnet mask. Your next home address is that 200, 200, 200.1, and that will be right. That's your lab 2 done. One lab is done. Now, this we have already done. Now I want to go and explain you the dynamic routing protocols. In our CCNA2 semester, we are going to explain 3 dynamic routing protocols. RIP, Routing Information Protocol, EIGRP, Enhanced Interior Gateway Routing Protocol, and OSPF, Open Shortest Path First. In RIP, you have 2 versions, version 1 and version 2. Version 1 can't do something. Version 2 has some advanced features, like it sends your VLSN information, it can do the summarization, that sort of thing. So it is always good to use the version 2. Okay. Now, if you want to do the dynamic routing protocol, your idea is always to get access to your remote network, or dynamic routing protocol always discovers the remote network. If you are here to implement a dynamic routing protocol, it could be version 1, 2, EIGRP or OSPF, anything. The idea is so that you know how you can go there. Being here, if you want to go there, that's a discovering your remote network. This one for him and this one for him is not a remote network. They are directly connected network. Can you see that? This one, R1 is directly connected to 192.168.1.0, and R1 is directly connected to 200.200.0. But R1 is not directly connected to 201, 202, 203.0. That's why we call this one remote network. Any dynamic routing protocol's purpose is to discover a remote network. So if we want to do that, we need to attach the directly connected networks near router. So if we do the RIP version 1, we'll type in R1 router, router RIP, and you should give a command called network. And as I said, we are going to attach here directly connected networks, not remotely connected networks. Your idea to discover it, to go and discover remote, you need to attach your directly connected ones. That's 192.168.1.0. Press enter. Again, you have another one, 200.200.200.0. Press enter. You are done. Yeah, sure. So this is for R1. This is for R1. So if I want to do the same for R2, this network is common in between R1 and R2. They are in between. So I need to type in R2 network 200.200.0, and this is another one for R2, the directly connected network. You need to type for R2 network 201, 202, 203, 204 in replacement of that. And if you have your serial interfaces configured, as I showed previous classes, how you do that, and if you configure all the interfaces are physically connected properly, now you should be able to ping from PC1 to PC2 and both directions. That's routing protocol read version 1 done. If you want to make a version 2, you just type after this, pressing enter, you just make another command here, version 2. That's it. That's how you make read version 1 to version 2. If you haven't typed anything, by default it's version 1. If you just add one line extra, it becomes version 2. So done, another protocol. Just another lab, just another lab. How many lines? Only 3 lines. Or maybe 2 lines. So this is then done. And if I take my board up there, for EIGRP, and I draw the topology again for you so that you are not missing anything. These are router 1, router 2, and BC1, BC2, 192, 168, 110, 200, 200, 0. These are the network addresses I write. All /24. But this one is /30. We know how and where it is because it is requiring only 2 devices. That's why /30. Now I'm going to explain another routing protocol EIGRP. How we do that? The same command in R1 router and the same mechanism. You are going to attach only your directly connected networks. That's it. But you have to remember something different now. So it is router EIGRP, and there is a value here for process ID. There is a value here. Sorry, there is a value here for EIGRP. This is not process ID. I was wrong. This is autonomous system number. What is autonomous system? Autonomous system is a single authoritative control. If you are in RMIT, all RMIT routers, computers, everything is under same control, same authorization authority. It's called an autonomous system number. It gets autonomous system number from a registry body. Okay. You need to specify who you are, where you are from. So you should give an autonomous system number. So in your lab time, we as a teacher will provide you for your topology autonomous system number is 10, 20, 100 or 1, whatever. We'll provide you. So as we'll provide you, just let's make this is autonomous system number 100. And now you do the same thing. No drama. The same thing we are going to type here. Network. As I'm in R1, this is my directly connected network. 100. Now in EIGRP, there is another thing you can add. Wildcard mask. Wildcard mask. Just to specify if this network was subnetted. It is not subnetted, it is class C. If you had a subnetted scenario like /27, 28, something like that, and you want to specify I want only /27 network, not the whole /24 network, then you could provide a wildcard mask. But as we are not that clear about that concept, leave it. We are not going to type anything here. We are not. And that will work because if we don't do that, that means it is taking the whole network, /24. And we are doing that. So just leave it. We need not to understand now. It will be in 16F4 level. We'll do this, but not now. Next time. So again, network. Another network you have. This is this. This is directly connected network. 200.200.200.0. Same thing you do for R2. When you are in R2, instead of this, when you are in R2, you need to add this in replacement of that because that's the directly connected network R2, and this one is the common in between R1 and R2. So you try this, done. Another lab finish. Now the last one, OSPF. The same way it works. It works the same way. In that case, we need to type in R1. If we are taking R1 router, we would type here router OSPF, and this is a process ID. not autonomous system number. And the process ID will be again given to you by your teacher. What is the process ID for that? And process ID is a locally significant number. You can have the same process ID in different routers locally. It's fine. Because it's locally significant. What process ID is doing here? What is the idea of having a process ID for OSPF? Because OSPF is a link state routing protocol. It depends on the status of the link and it doesn't do periodic update, rather it does the partial trigger update. So it is only looking for, is there any change in the topology at this moment? If it's not, I'm not going to update anyone. There is no point of updating every 30 seconds like RMIT used to do if there is no change. If there is a change, I'm not even going to update everyone because maybe everyone is not interested about the change. Only Shavi is interested. I'll tell Shavi, the network I was connected to, you will be affected if you haven't updated yourself. This is the change. So that's partial update and that's trigger update. Once there is a change, it's triggered and I update it. OSPF works that way. But who in the OSPF topology among some 5, 10, 20 or millions of routers, who will update? Who will take the role to update? Not everyone will update everyone. Like RMIT used to update everyone to everyone. It consumes the bandwidth. If all of us in the class start talking, it will be interference, it will take bandwidth. So instead of doing that way, OSPF makes some router a designated router. So you are designated, you are the leader, you update everyone when there is a change and whoever needs it. So that thing is identified, represented by process ID. There is a discussion about that. We are not going in that detail. So for that to specify who is the designated router in our topology, we should have a process ID. Process ID number will be given by your teacher. So let's make the assumption process ID here is 1. I gave you, it's provided to you. The same thing you do directly connected network. Network 192.168.1.0. Here you can have again the same thing, wildcard mask, followed by your area 0. If you don't want to use that, you can avoid this. Then it will do the same thing like EIP. It will add all the network members, not a subnetted network member. If you don't do the wildcard mask. If you do it, you may wait. It's an advanced option. So we just leave nothing we put here. In the lab, it may say a wildcard mask. That's another thing to understand. I will explain in the next class what wildcard mask, how we calculate the wildcard mask. In here, it should always keep this area 0. Now, area is what? In OSPF, the way it works, it is clubbing some different routers under some different area. If you work as a backbone for some others, the number for that backbone area is called area 0. It is by default that you cannot change area 0 to something. Area 0 is always preset, predefined backbone area. Any other areas who are taking the services of backbone area are called non-backbone area and non-transit area. Backbone area and transit area same. Non-backbone, non-transit area are normal areas. Under that, you have some number of OSPF things, OSPF routers. So we are not using different areas here. All the routers are under the same area because we don't know multi-area OSPF concept. So we leave it simple. We make it only area 0. That's why you always see area 0. We will not tell you use area number something different, 10, 15. If we even say in question in the lab exam area 15, that means you have only one area. We are not going to configure in CCNA level multi-area OSPF. So if I give you an area number that represents all the routers under the same area, we don't have any backbone area. Is it clear? So do the same thing from R2. Router OSPF, you can take number 1 or you can take number 10, whatever, because it's locally significant. Do the same thing network, that is your directly connected network and your another directly connected network, 200, 200, 200. No 0, you can avoid it, so area 0. Done. We finish some more labs. Now if I actually can you see these are same thing in all different routing protocols? Same thing. So what I'm going to sum up in one single slide now, what I'm going to, maybe it can be better if I take it down. If I take the topology R, for static routing, I'm writing for only one side router, R1 in our case. IP role, the syntax is destination network address followed by subnet mask followed by either adjacent serial interface or next hop address. This is in one direction. You need to do for the other direction as well, other router as well. For router read, the same thing. All these things should be in config mode, remember. And you do router read, and now you add your directly connected networks. How many networks you are directly? In our case, it is only 2. You might have many, and as many as directly connected network you see, you need to attach, you need to assign all of them with you. In our case, it's only 2, but it might have 3, 4 if you have enough interfaces. So network and then network address. Okay, that's read. Now, if I like to use the same thing, if I use the EIGRP, then router EIGRP, that will come here. Not read, not EIGRP, same thing. Here in EIGRP, you could write one-cut mask. You could write one-cut mask. Anything I write in do now, that is for read EIGRP configuration. Same thing, but just a little bit change. And followed by your autonomous system number in the first line. That's how you do EIGRP. If I do the same thing for OSPF, you just write router OSPF followed by process ID. And same thing, network address followed by one-cut mask, or so you can have one-cut mask followed by your area 0. Done. Lab 1, 2, 3, 4. I started quarter to 11, now it's quarter past 11. Half an hour, we understand now 4 different types of routing protocol. 3 are dynamic routing protocol, 1 is static routing. Okay. Now one thing I missed here, if you make read version 2, if you write version 2, it becomes read version 2. This is read version 1. If you don't do that, read version 1. If you do this line, it becomes read version 2. Okay. Now if you do that, and this command I am writing now, it will be same for all. You can write no auto summary. Why we are doing no auto summary? Because read version 2 EIGRP by default, based on their phrase properties, they auto summarize your network address. So what it means if you use the one-cut mask, that means you use some subnetted network address, not the whole big network. You type in your you type here, for example, 192.168.1.0, and for example, maybe it was /27, and you type here the sub one-cut mask 00 whatever 27, that's 5 248, so 7. That's the one-cut mask. You type these. I am not explaining what one-cut mask is, but it is a subnetted address. But when you give the command show run, if you don't this print command, go to summary, it will automatically summarize and it will show you 192.168.1.0 and it will be /24, but not /27 because it's already summarized to your major network boundary. This is a problem. I didn't want to mean the whole network. I wanted to mean /27. As I didn't give this command, it shows me show run the big network. And once you use the second available network of your big network, it says network overlaps. What I'm trying to say, you have this big network, you split it, separated 1 and 2. Now you want only these, but as you haven't configured this line, you missed it, you forgot it. Now it is accepting the whole big network. Now once you are trying to give this network to someone else, it says it's already given because he is considering the whole big network given to someone. But you didn't do that, you didn't mean that. You mean to give this one to someone, this one to someone. Different person, different network. But as you forgot this command, he is saying you gave already the big network. How you can give the same network to different person? You can't. That's happening for this. Read version 2, EIGRP, you must give this no auto summary. And we finish the whole thing. Thank you very much.